All right, time to talk a little bit about soil and what we kind of need to know to understand soil management for our pastures and forage crops. Rule 1, it is not dirt. I used to joke around about that all the time. It is soil. And the reason it's soil is because it's more complex than just dirt. Soil is that natural medium for the growth of the land plants and the source of 13 of the 16 essential plant nutrients that we've talked about. Knowing that carbon, hydrogen, and oxygen and some of the nitrogen come from the atmosphere, the rest of that is all coming from the soil. And so we need to understand how it's developed and built to be able to utilize it to the best of its ability. 4 major things that make up soil: minerals, the organic matter, water, and air. And we're going to talk a little bit, those minerals that are in that soil, that's what's going to get put into solution in the soil water. And then we also have the air spaces within that so that that soil solution can travel through the soil to get to the plant roots to be allowed to be taken up. Organic matter is that material that's going to constantly be broken down to generate the minerals that are present in the soil. When we talk about soil organic matter, I just want to kind of keep it in perspective of where we're at. And this is the general soil organic matter or organic carbon globally. And you'll notice in the U.S. that it's the upper Midwest that has a ton of soil organic matter. That's where a lot of our rich farmland is in that direction. You'll also notice you see the Central Valley of California that has high in soil organic matter. Through Europe, through India, a lot of these different places you can kind of see where that organic matter is prevalent. If we take a look within California and in the western U.S., or in the U.S. in general, you'll see that Midwestern region that has a lot of organic matter, the Southeast, and the Pacific Northwest. You'll notice that Nevada, California, Utah, Arizona, New Mexico tend to have a little less organic matter. The Central Valley of California has quite a bit compared to some of the other regions. But it's definitely, that's more that arid southwest, perhaps, and doesn't have quite the organic matter some of the other regions do. When we look specifically at California, you'll see that we, compared to other regions of the country, we're actually not very high in organic matter. When you get along certain regions, like up on the coasts, you'll start seeing an increase in the organic matter. In the north end of the Sacramento Valley, you'll see an increase in organic matter and smatterings around. But we need to pay attention to our organic matter in our pastures and or farmland. Why we care so much about soil minerals and organic matter is that they are the sources of those nutrients, and that's where the nutrient cations are retained in the soil in that organic matter. And so we want to make sure that that's continually, slowly releasing nutrients to sustain our plant growth. Most of the nutrients that are going to be taken up by the plants is taken up in soil solution, that soil water. But only a small portion of the total nutrients in the soil is in soil solution at any one time. So we rely on that organic matter releasing nutrients during decomposition and actually doing it at a relatively slow and steady rate to make sure there's a consistent supply for our soil solution to get nutrients up to the roots. Couple terms that we need to be aware of when it comes to discussing nutrient holding capacity of our soils. The first is the pH dependent charge, and that's going to be determined by the amount of clay or type of clay that's in the soil, the amount of the organic matter, and the overall pH of the soil. That's going to affect some of the nutrient holding ability. The second one is the cation exchange capacity, or CEC. You'll see that on soil test analysis. And that's the ability of that soil to retain nutrient cations, meaning the higher the CEC, less leaching. More ions are being held in the soil, thus increasing the likelihood that those cations can be taken up by our plants. The next factor we need to just be aware of is soil acidity. And like acidity in anything, it's a measure of the hydrogen ion activities. This specifically is looking at the soil solution. And if we had one thing that truly affects everything else in a forage soil ecosystem, it's acidity, the pH of the soil. It's a major factor affecting all the organisms, both the earthworms, the microorganisms. Everything's going to be affected by pH. All the plant nutrients are going to be affected. Some are released at certain pHs, others are retained in other pHs. And all of that, if we're affecting the microorganisms and the earthworms and all the biota that's at the soil-plant interface, as well as the plant nutrients, then ultimately we're going to be affecting plant growth and development. One of the things that happens is when soil becomes really acidic, that means we have lots of hydrogen ions and quite a bit of aluminum present, and we would like to avoid that. Once the pH of soil hits around 5.5, then we start losing nitrogen fixation, we start losing the microorganisms and the bacteria that are going to help with decomposing any of the organic matter, and it shuts down the entire sulfur cycle. And so we need to pay attention to our soil pH. And here's one of the major reasons. What happens is how it affects plant availability of plant nutrients depending on where you're at. So if you're in that neutral pH of around 7, that's where we actually have pretty optimum levels. If you go with green as being high release of those nutrients, that's where we've got a lot of nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, the big ones that we've already talked about. However, as you start getting into more acidic soils, you'll start getting to some of the micronutrients, and even some are extremely alkaline. So it kind of depends on where you're wanting to be at. Generally, we're wanting to be between a 6 and a 7, somewhere in there. On this diagram, it's 6.2 to 7.3. That's allowing us to maximize most of our plant nutrients. If we take a look at some of our common forage plants that we've been talking about, and those that are the least acidic or tolerate the least amount of acidity is alfalfa, sweet clover, and barley. One reason that we grew alfalfa really well in Nevada is we have alkaline soils. We definitely are in the almost 7 to 7.5 pH range. And so we have very alkaline soils, and that's what alfalfa does extremely well in. So we were able to raise that fairly well. But then you'll notice that our grasses and our clovers and even bird's foot trefoil, they like a little bit more neutral pH to slightly acidic, somewhere in that 6 to 7 range. And that's generally what we're going to shoot for our forage crops that we deal with minus alfalfa and barley. So in order to best manage your forage system, you need to know what plants you have in that system and understand what pH ranges they like. Because I was never one that we did a lot of liming of our soil for our alfalfa fields. If we needed calcium, we'd apply some gypsum, but we never wanted to really lower pH because the soil was really set up for our alfalfa. The last thing and concept that we need to understand regarding plant nutrition, soil nutrients, is Liebig's law of the minimum. And this was established in the 1800s. And his law states that if one growth factor or nutrient's deficient, plant growth is limited, even if everything else is adequate. And that plant growth is going to be improved by increasing the supply of that deficient entity. If you look at the barrel diagram, and if you picture plant nutrients like a barrel and the slats are different heights, you'll see that, okay, we've got plenty of warmth, light, and water, but our first limiting nutrient happens to be nitrogen. So until we patch that nitrogen and fix it, then we are going to be deficient in nitrogen, and that forage growth is not going to be able to grow beyond what's available. But if we were to perhaps fix nitrogen, then maybe phosphorus or calcium would be the next limiting nutrient. And so Liebig's law of the minimum just states that the lowest limiting factor is what's going to be limiting growth. and that just by adding nutrients doesn't mean you're going to see a response in the plant. For example, if we're looking at the barrel that we have here, and we decided we need boron, we're going to apply boron. Is it going to do you any good to apply boron when you're deficient in nitrogen? No, you've got to fix the deficiency first before you see any benefits from the other nutrients. And that's why it's so important to soil test. That's why it's so important to understand what the macronutrients and the micronutrients are, and understand what your soil has to offer for your plants. Okay, that's going to wrap up the soil nutrition, plant nutrition section for the semester.